My name is Jeff Bogert. The video that you're seeing illustrates a Python program called heredity.py that was implemented as required by the Harvard's online course CS50's Introduction to Artificial Intelligence with Python. The inputs to the program are data sets that depict various family structures and probability data concerning a specific gene which affects the hearing of people. The program uses the data to calculate the probabilities for the people that are in the data sets that they have either a 0 or 1 or 2 copies of the gene that produces the hearing difficulty, and the probability that they express that hearing loss, which is known as a trait. The first data set consists of a child named Harry. That's at the very top of the screen on the left-hand side, and that child has a mother named Lily. She's the third one down in the list. And the father's name is James. And we are told, as you can see in these numbers underneath show the probability. They will have the gene with 2 copies, 1 copy, or 0 copies. And those numbers for those different combinations all will add up to 1. And then on the trait, the 2 numbers, one is for not having the trait and the other is for having the trait. So having the trait would be true and false would be not having the trait. And again, those probabilities add up to 1. And as you can see, for the mother Lily, it is false that she exhibits this trait. And for the father James, it is true that he exhibits the trait. And what we're seeing by running the program through all the combinations of probabilities and how they inherit from the parents, Harry has a small probability of expressing this trait and a false probability of being false of about 75%. Also, you see that it's a very low probability that he will have 2 copies of the gene. He will have almost a 50% chance of having 1 copy or 0 copies. So again, the program goes through the calculations for this particular family. This is data set 0. And that data set has this one family in it, Harry with his mother and father. And we learn about the different probabilities. There is also an unconditional probability that you would get this gene independent of whether your father or mother had it. All that gets wrapped into the numbers that you're seeing. So I've gone through the 3 data sets, the data set 0, which is this data set. Now we have a data set called family 1, which has another combination of fathers and children. And again, we're asked to calculate for everyone in the family their probabilities of having the gene, 1 or 2 or 0 copies, and of expressing the trait with a true or a false. And again, you can see that some people have a total probability that they don't have the trait, or a total probability they do have the trait, and others inherit a probability from their parents. The last data set is even more complicated. It shows a family that has children, and then those children have children, and we go through essentially 2 generations of calculating the probability they have the gene, 1, 2, or 3, 0, 1, or 2 copies, and whether or not they express this trait with a true or false or some other probability in between. That's, again, this is done for CS50's Introduction to Artificial Intelligence using Python, and we have discussed how to see gene transferal. Thank you very much.